Hello, grade 12. In today's lesson, we're going to be looking at organic chemistry, the exam questions approach simplified, and let's see what we got. So we have Eastern Cape, September 2022. That was last year prelims exam. So we have the letters A to D in the table below represent 4 organic compounds that belong to different homologous series, right? So I'm gonna give you a simple and easy approach to these questions. So if you have this approach, this method, you can just answer your questions in like less than 5 minutes, just like that. So let's just deal away with the definitions and let's get to the approach. We have 2.1. It says define the term homologous series. So homologous series is a group of organic compounds that can be defined by the same general formula where each member differs from the previous by a CH2 group. Now, okay, let's get to the approach. So basically what I do every time I see these questions is I will try to write out the homologous series of each and every organic compound that I've been presented with there. So all the way from A to D, let's just try to write our homologous series. So here from anal, we can see that this belongs in the aldehyde homologous series. So aldehyde homologous series. You can still remember that from your notes. And then here from the functional group, the carboxyl group, we can tell that this belongs in the carboxylic acid homologous series. Now compound C, from that triple bond there, we can tell that this belongs in the alkyne homologous series. And then compound D, from the suffix ane, we can tell that this belongs in the alkane homologous series. Now that's it. Now that's what you do before you even read the questions. Try to fill out the names of the homologous series of each and every compound, and then you can go and read the questions. Now let's go. 2.2, it says write down the letter that represents a saturated hydrocarbon. Now let's highlight our keywords there. We have saturated hydrocarbon. You will remember from our notes that we said hydrocarbons are compounds that are organic compounds that only contain of carbon and hydrogen atoms. Now from the homologous series that we have given above, we can tell that the only homologous series that have compounds with hydrogen and carbon atoms only are your alkynes and your alkane. Now let's look at the word saturated. You will remember that we said saturated hydrocarbons are hydrocarbons whereby there are single bonds between the carbon atoms. So which one is single bonds between your alkyne and your alkane? We know it's an alkane. So that means the correct letter here is D. So pentane is a saturated hydrocarbon. Then 2.2.2 says the general formula of the homologous series to which compound C belongs. Now that's compound C, but in order to determine the general formula, we'd have to know the homologous series in which it belongs. Now there is no need for us to stress about that again because we already wrote that analyzing the question. So it's an alkyne. Now it's just a matter of us writing the general formula of the alkyne. Now you will remember the general formula from our notes for alkynes was CnH2n minus 2. Now 2.2.3 says the structural formula of compound A. The structural formula of compound A. Now that we've already written that compound A belongs in the aldehyde homologous series, now we know how to draw this. We know that it has a formyl functional group which is always attached to the first carbon atom. Now we have propanol, prop. From prop we know that we must have 3 carbon atoms in our longest chain, but then we have 2 methyl. That means our methyl branch is attached to the second carbon. Let me erase here. Is attached to the second carbon. Now here we go, our formyl group in the first carbon. and then we just insert our hydrogen atoms, and that's it. That's 2-methyl propanol. Awesome. Then 2.3 says write down the IUPAC name of compound B. The IUPAC name of compound B. So now we know that compound B belongs in the carboxylic acid homologous series. So it's just a matter of giving out the name. So we know when naming, we first count the number of carbon atoms. So we have 1, 2, 3, 4, 5 in our longest chain. So let's confirm that that's the longest chain. We go 1, 2, 3, 4, 5. So even if it curves like that, it's still 5 carbons. So that means our longest chain is pent. Then let's look at the substituents that we have. We have in number 2 our methyl branch, and in number 3 we have our ethyl branch. Now if you can still remember the alphabetical order rule, it says ethyl will always come before methyl because E comes before M. So this is how we're gonna have it. So it's gonna be 3-ethyl 2-methyl. But remember, we have 5 carbons, so this is pentanoic, since it belongs in the carboxylic acid group, homologous series. So we have 3-ethyl 2-methyl pentanoic acid, and that's the name, the IUPAC name. Then it goes 2.4. Compound D has 3 structural isomers. Now compound D, remember, is an alkane, and then we know the structural isomers of alkanes most of the time are your chain isomers. But then let's read. It says write down the structural formula of the isomer with the shortest chain. So that confirms that we are dealing with chain isomers. So pentane, from the word pent, we know that's 5 carbons. So we are looking for a way to write down a structural formula with 5 carbons but with the shortest chain. So we go, okay. So to make a short chain out of 5 carbons, we can have this, and then put the other 2 carbons here as branches or alkyl groups. Then just fill in our hydrogen atoms. Then you can see that, that's H, H, H. So now we have the formula C5H12, which is the same as for pentane. Remember, your chain isomers are compounds with the same molecular formula but different types of chains. Same molecular formula, belong in the same homologous series but have different types of chains, right? So pentane is straight chained, but this one that I've drawn here is branched. Now 2.4.2 says write down the balanced equation for the combustion reaction of compound D in excess oxygen using molecular formulae. Now you will remember that our combustion reaction, so basically the general formula for combustion is you will add a fuel plus excess oxygen gas to always give you CO2 and water, right? So here we have compound D. Our fuel is compound D, which is pentane. So that's C5H12 plus oxygen gas, or then CO2 plus H2O. Right. Now it's just a matter of having to balance this. So now what do? We use the Chor method. What is the Chor method? Basically, it means first look at the carbon atoms, try to balance them out. Then look at the hydrogen atoms, balance them out. Then lastly, look at the oxygen atoms and balance them out. So now let's see. Here we have how many carbons on the left hand side. So this is left and this is right. How many carbon atoms on the left hand side? We have 5. And how many carbons on the right hand side? We only have 1. So how do we ensure that we have 5 carbons? We can just put 5 just before carbon there. So we have 5 times 1, that's 5 carbons. So the carbon atoms are balanced. Then let's go to the hydrogen atoms. We have 12 in the left hand side and we only have 2 on the right hand side. So how do we ensure that they are balanced? What number can we multiply to 2 so that it gives us 12? That's 6. So we can put 6 here. Now that 6 times 2, we have 12. So the hydrogen atoms are also balanced. But now let's come to the oxygen atoms. On your left hand side, you only have 2 oxygen atoms. But on your right hand side, now you have 5 times 2, which is 10, plus the 6. Remember, this is 6 times 1. So this is 10 from here, and then plus the 6, it's 16. So how do we ensure that the oxygen atoms are balanced? What number can we multiply to 2? That will give us 16. It's 8. So we put 8 here, and then it's balanced like that. So you have full marks for writing out your equation and then balancing it out. Awesome.